So when we have two waves which are traveling in opposite direction, this will result in a formation of a standing wave. And we can have a standing wave in a string. So we may have a standing wave in a string, as you can see here. This is a standing wave in a string. We may have a standing wave in an open pipe. Open pipe means a pipe which is open from both ends. We may have the standing wave, or we may have a standing wave in a closed air column or a closed pipe. So what is the formula? Like example, when it vibrate, always the close end, it will form a node. That is a fundamental. So this will be one node and one antinode. That's a fundamental. Or may have a node, antinode, node, and antinode. Or we may have a node, antinode, node, antinode, node, and then antinode. So always at the open end, it will form an antinode. Now, what is this length in terms of the wave? Like the length of the air column is L, like length of the open pipe, closed pipe is L. So what is this distance in terms of the wavelength? How much is this distance? The distance between the node and the antinode. So the distance between one node and one antinode, that is quarter of the wavelength. So we can say if this was lambda 1, we are saying, so this will be for one loop, we are saying lambda 1. So this will be lambda 1 by 4. So we can say the for one loop, it will be lambda 1 by 4 is equals to L, or L is equals to, or wavelength is equals to 4 times L, or 4L. As you can see here, fundamental. Same thing, if we have the first overtone or the second harmonic, first overtone is called second harmonic. What is this distance? Distance between the nodes, the two successive nodes, that is lambda by 2, and the node and antinode is lambda by 4. So when we add them, so lambda by 2 plus lambda by 4, so 4 will be an LCM, so this will be 2 lambda by 2 plus lambda by 2. So this total will be 3 lambda by 4. So length, in this case, so 3 lambda by 4 is a length. So if we need lambda by 2, so this will be 4L by 3. So that's 4L by 3. And if it is vibrating, the second overtone or the second overtone is there, or the third harmonic. So this is lambda by 2. This is lambda by 2. And this is lambda by 4. So when you add them, you have lambda by 2 plus lambda by 4. So 4 will be in LCM. So 2 lambda plus 2 lambda plus lambda. So this will be 5 lambda by 4. So 5 lambda by 4 is L. So lambda will be equals to 4L divided by 5. So 4L divided by 5. And if we need the speed of the wave, how to work out the frequency? So we have the formula V is equals to F lambda. So V is a speed, F is a frequency, and wavelength, that is 4L. So this is multiplied, other side divided. So we'll get the frequency will be V over 4L. If it is vibrating in two loops, as you can see here, so if it is vibrating in two loops, the wavelength is 4L by 3. So if we substitute in the formula, V is equals to F lambda. V is the speed, F is the frequency, and lambda, that is 4L by 3. So if we simplify, it will be 3V over 4L. That is F. So that is 3V over 4L. That is a frequency. And if it is having a second overtone or the third harmonics, so the distance between the two successive notes, that is lambda by 2, and lambda by 4. So when you add them, lambda by 2 plus lambda by 2 plus lambda by 4. So 4 will be an LCM. So this will be 2 lambda plus 2 lambda plus lambda. So this will be equals to 5 lambda by 4. So L is 5 lambda by 4. or lambda is 4L divided by 5. That's we get the formula. And if you need the speed, so V is equals, if you need the frequency, V equals F lambda. So in that case, it will be 4L by 5. So if we need F, it will be V over V into 5 divided by 4L. So in short, the frequency for, if we say the frequency for the first harmonic is F naught, the frequency for the second harmonic will be 3 times F naught. So it will always be the multiple of odd number. Like if it is vibrating, first one is F naught, second one will be 3F naught, third one will be 5F naught, fourth one will be 7F naught, fifth one will be 9F naught, sixth one will be 11F naught, and so on. So if the first frequency is F naught, the second will be 3F naught, the third will be 5F naught, fourth will be 7F naught, 9F naught. F naught means like the original frequency, 11F naught, and so on. This is in a closed pipe. But if it was open pipe or a string instrument, what is the difference here? If the first frequency is F naught, second will be 2F naught, 3 will be 3F naught, 4F naught, and so on. That's a difference in the frequency. So the closed pipe produce a higher, if the number of the loop changes, the frequency will also change. And it change by a multiple, a factor of odd number like 1, 3, 5, 7, 9, 11, and so on. Is it clear, the concept of the standing wave? Anyone having a doubt or a question till this point? So this one is an assignment which is having the questions related to the standing waves. You can use a chat to answer the question. Standing waves, two waves of wavelength lambda from a single source diverge and then meet again. Which of the following situation could cause a constructive interference? A constructive interference. Remember, in terms of the phase, when we have a phase difference of 0 or 2 pi, it will be a constructive. And when we have a phase difference of a pi, it will be a destructive. So this phase, we want a constructive interference. So we want 0 or pi. So phase difference of pi means this will be a destructive interference. Phase difference of the pi by 2 cannot be constructive or destructive. It will be a combination. We want a complete. So mean this will not result, because when there's a pi by 2 or a 90-degree, some places there will be constructive, some places destructive. But we want a complete, cause a destructive, constructive interference. Now we are left with two of them. A part difference of lambda by 2. What does it mean, the part difference of lambda by 2? A part difference of a lambda by 2 means, like example, if this is source 1 and this is source 2, say this wave completed 3 waves as from source 1. And for another point, other wave 1, 2, 3 and 3.5. So as you can see here, one wave has completed 3.5 wavelengths and another wave has completed 3 wavelengths. So what is a part difference? Part difference means like in terms of the wavelength. What is the difference in terms of the wavelength? The part difference is half wavelength. If the part difference is equals to half wavelength, So the path difference is equals to half wavelength. What does it mean? It means the crest of the one is joining with the trough of another. When crest of one join with the trough of another, what we'll have at this point, we'll have a destructive interference. So it cannot be A. What about B? It will be, the B is the right answer. How B is the right answer? What does it mean? Like example, we have source 1 and we have source 2. When the two waves combine, say 1, 2, and another wave 1, 2, and 3. So you can see the trough of another, like this is a 3 wavelengths example, and this is 2 wavelengths. So what is the part difference in terms of the wavelength? 3 wavelengths minus 2 wavelength. So part difference is lambda. When the part difference is lambda, they will have a constructive interference or constructive combination. About this type of interference, when the two waves are produced from a source, different sources, that is our next topic. Actually, this is not a standing wave question. This is a question related to interference. An experiment is carried out to investigate the speed of a wave of a transverse wave on a stretched string of a length L. A vibrating generator causes the string to oscillate so that the stationary wave is produced. Look how this stationary wave is produced. A vibrating generator, as it oscillates or vibrate, it will produce a wave. That wave will hit this point Q and it will bounce back. So there are two waves which are traveling in an opposite direction. One is from the source, one is the reflected. When these two waves will meet, the combination of these two waves will give rise to a standing wave. That is how the standing wave is produced. Determine the wavelength of a wave when the string is vibrating and shown, as shown. First thing, so this is a node, 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 and a node. So how I can relate a wavelength with a length here, because the distance between three successive nodes is lambda. So this is lambda and this is also lambda. So what is this total length? So I can say L is equals to 2 lambda. So if L is 2 lambda, I need a lambda. How I can get the lambda? So it means length divided by 2, I'll get the lambda. So L by 2 will be equals to lambda. So wavelength will be equals to L by 2. So 1.7 divided by 2, so we'll get 0.85 meters. Is it clear how we worked out the wavelength of this wave? The next is calculate the speed of the wave on the string, the mass of 0.2 kg and the mass per unit length is given. How we can work out the speed of the wave? V is equals to under root T divided by mu. That is a formula I gave you that's we can use. We can use V is equals to F lambda as well. But the problem we know the wavelength, but we don't know the frequency, as the frequency is not given. So the another formula to get the wave, the speed of the wave in a string, it is under root T divided by mu. What is T? T is the tension. So how much is the tension? Because the weight of this object is acting downward, and that weight is actually the tension in the string. But by what force the string is being pulled, that is called a tension in a string. So tension in the string is actually equals to weight. And how to get the weight? Weight is mass into gravity. So tension will be mass times the gravity. And the mass per unit length is already given to us. So V is equals to under root T divided by mu. So T is the mass into gravity. Why? Because that's a weight. And the mass per unit length, this is mu is given. The mass per unit length is given. And this. So this will be the speed of the wave when you substitute 0.2 into 9.8 divided by 4.5 into 10 to the power negative 3 in a root. You will get 20.9, which is 21. So 20.9 meters per second or 21 meters per second. You can round it off to two significant figures. Frequency of a vibrating generator is reduced. And how you know the frequency? Because as you can see, if you reduce the frequency, the mass is stationary. The mass which is attached here is not changing. That's why the tension in the string is constant. We can change the mass by adding a different load. The frequency of a vibration generator is reduced until the wave pattern is shown. Explain the effect that would have on the speed of the wave in the string. Will affect the speed? Yes or no? Any effect on the speed? There's no effect. No, the speed of the wave never changes until the speed of the wave can only change, depends on under root t divided by mu. If we change the tension or the mass period length, then only the speed will change. So speed will remain constant. Speed will not change, so the speed will remain constant. And how the speed will remain constant? Because we are not changing the tension or the mass per unit length. And in terms of the frequency and the wavelength, speed is frequency multiplied by the wavelength. So as we reduce the frequency, if the frequency is reduced, the wavelength will increase, but the product will remain unchanged. So speed of the wave in a string can only be changed if you change the tension or you change the mass per unit length. So one mark for mentioning it won't change. And the second mark is if you decrease the frequency, the wavelength will increase. Two waves from a same source arrive at a point with a path difference of T lambda by 8, where lambda is a wavelength. Which of the following is a phase difference? How you can work out this you can compare like when we have one wavelength, what is the relation, the phase and the path? When we have one complete wavelength, like lambda is there, when we have one complete wavelength, the phase difference will be, the angle difference will be 360 degrees, or the path difference will be lambda. So means 360 degrees, the phase difference of 360 equals to path difference of lambda, like one complete wavelength. So if we have 3 lambda by 8, how much is a phase difference x cross multiply? Is it clear? Because when we have a phase difference of 360 means the path difference, same idea like example, when you have a phase difference of 180, what will be the path difference? Path difference will be lambda by 2, half wavelength. So if we have a phase difference of 360 or one complete wavelength, the path difference will be lambda. If we have a phase difference of, if we have a path difference of 3 lambda by 8, the phase difference will be x, cross multiply. So 360 times 3 lambda by 8 is equals to lambda into x. Lambda will cancel with lambda. So what's the answer? 360 into 3 divided by 8. That is 135. So x is equals to 135 degrees. So C will be the right answer. Is it clear? This one? The next is Active noise reduction, or ANR, is a system used to reduce the unwanted noise. In ANR, a second sound wave is produced that cancel the first. ANR is used in aircraft to reduce the noise which is heard from the engine. On a particular flight, the noise from the engine has a frequency of 0.85 kilohertz. The graph shows shows a possible second wave. Determine whether this wave could be suitable to cancel out the noise from the engine. The speed of the wave is given. So what we can do first, we will work out the wavelength which is produced, because determine the wave, determine whether this wave would be suitable to cancel out the noise from the engine. The engine has a frequency of 0.85 and the speed of a sound is. So what is the wavelength produces by the engine that we first find? So V is equals to F lambda. So lambda will be equals to V divided by F. The engine is producing a sound wave with a speed of 340 and the frequency of the wave is 0.85 kilohertz. So 0.85 into 10 power 0.85 into 10 power 3. What's the answer for this? 340 divided by 0.85 exponent 3. So it is 0.4. So means the wavelength of a wave which is produced by the engine is having a length of a 0.4. 0.4 meter. What is the wavelength of this wave? What is the wavelength of this wave which we are producing to cancel out the second possible wave? So this is 0.1, this is 0.2, 0.3 and 0.4. So that is also having a 0.4. So same wavelengths are there. So mean this wave is suitable. Like this is a wave which is produced by the engine, and the wave which we are producing, the noise cancellation, active noise reduction or noise cancellation headphone, we are producing this. This is produced by that, the ANR. So ANR is producing a same wavelength as the sound wave. So as a result, it can cancel out each other. If it was like shorter or a longer wavelength, then it will not be suitable. Is it clear? This concept? Now, another example, for a particular passenger in an aircraft, the noise from the engine travel as a wave towards the passenger from the front. An ANR system create a second wave that is in a direction towards the passenger from the side. So example, this is representing a passenger in an airplane. So sound from ANR system is there and noise from the engine in this direction. Explain how this can lead to the sound being cancelled out from one ear but allowed for the other ear. So how this will lead to, basically, and it's of 6 marks, you have to use the proper terminologies to answer this type of a question. Now, what will happen? This is a sound from ANR system, okay? The system which is producing a sound to cancel out this noise from the engine. So how one ear might hear a louder sound, like, and the other ear, it might cancel out each other. So what might be the reason or what could be the reason for that? So as you can see, sound from the ANR, when it is passing, the sound which is passing from this ANR, say this is representing a sound waves. These are the wave fronts I drew. So when it passes, it will diffract. This is the sound. So means on the left hand ear, the sound is directly reaching. But on the right hand side, on the right ear, the sound is reaching after diffraction. As a result of the diffraction, what will happen to the intensity of the sound? Because of a diffraction, what will happen when the wave diffract? So the intensity of the wave which was produced at this point, the intensity will decrease. So intensity of the wave which is at this point will be different from intensity of wave at the other right hand ear. So the noise from the engine is having a constant amplitude. Like example, noise from the engine is having an constant amplitude. So as a result, when they meet each other, they will cancel out because they have the same amplitude. But when the noise from the engine meet the right ear and the wave because of a diffraction from a sound from ANR system, it cannot cancel out completely. Why it cannot cancel out completely? Because this is having a lower amplitude, but the sound from the engine is having a higher amplitude. Because of a diffraction, the amplitude decreases. So as a result, when the amplitude decreases, it will cancel out, but it will not completely cancel out each other. And I should draw, because I want to cancel out, so I should draw 180 out of phase. So example, this is the wave which is produced. So in this case, the green one is green one is from the engine and the black one is from ANR system. So in this case, what will happen? A person will hear some sound on the right ear. But one which is directly reaching the combined with the noise from the engine. So as a result, say this is from ANR and this is from the engine. So they completely cancel out each other. That's why there will be no sound at this one and there will be a loud sound on the right hand side of the ear. So what actually happened, the sound which is moving like from the left hand side. So the ANR system, it is diffracted from the phase. As a result, there will be an interference on the left hand side as well as the right hand side. The left hand side ear, the amplitude is same, so it will completely cancel out. But on the right hand side, the amplitude from the ANR system is not same as the sound from the engine. So it will cancel out, but not completely. So that as a result, there will be a sound on the right hand side. Is it clear? Anyone having a doubt or a question in this? So these are some questions from standing wave. More we'll do in the next session as we are done with this topic of a standing wave. Anyone, any doubt or a question related to the class today?